Hi everyone, myself Puneet Reddy, application engineer from the UTS. So now we will see the ARM7 architecture. What is an ARM7? What are its features? What it contains? Everything. After that, so that it will be easier whenever you are working on a LPC214. It's a ARM7 based controller. So we will see the architecture features today. So first of all, what is an ARM? What it means, why it is so much famous, all those things. So actually, ARM stands for Advanced Risk Machine. It's a term, and it is developed by the ARM company. So first of all, there is the company name is Acron Risk Machine, original name. So after that, due to its architecture, which is developed by this Acron machine, as so much as popular in the world. So the company name has been changed from Acron Risk Machine to the Advanced Risk Machine, and this ARM company develops the architectures only. So it is not making any kind of ICs. So it's build up only the architectures, and that too the 32-bit RISC architectures. So I think all of you know the RISC. It's a instruction set architecture, reduced instruction set architecture. Of course, we will see the further. So most of these ARMs are used in the case of electronic goods. I mean, in the case of consumer electronics, or in the case of all most of the embedded systems consist of this ARM architectures, 95%. So and moreover, this ARM architectures, ARM controllers, ARM architecture based controllers are dominated in the case of mobile electronics. That means most of our mobiles, kindly 8000 above kind of mobiles will have this ARM architecture internally in the ICs. So next of all, whenever we have doing any kind of we are working on any kind of controllers, we have to know some kind of history of that one also. So the history of this ARM controllers is nothing but Acron computers. So first of all, this ARM architecture is developed by the Acron computers. After that, this Acron computers company name has changed to Advanced Risk Machines. So in the 1983 it is founded, and see, the ARM company develops only the architectures, and it sells those architectures to different kind of companies. So those companies which will buy this ARM architecture from the ARM companies will make ICs using that architectures. So that is nothing but selling licenses to the different core companies, the ARM company. So the Apple, the topmost company in the world itself, is having this ARM architecture license. So you can imagine how much importance with this ARM architecture, with this example. So not only the Apple company, there are the famous companies also having this ARM architecture licenses. So Texas Instruments, Samsung company, Atmel company, Intel company, all of you know the Intel companies, also IBM companies. So all those things will having this ARM architecture key licenses. So as I said, every IC should have its own backbone. That means nothing but its own architecture. See, all of you know the 88NC51 controllers. It's a 8051 architecture based controllers. So 88NC51 is your one IC. That IC internally having some kind of architecture known as 8051 architecture. So in the same way, our LPC2148 controllers which we are working, so that controllers also having some kind of architecture internal to that IC. So that is nothing but backbone. So whenever we are doing any kind of whenever we are working on any kind of ICs, we should know what is the architecture internal to that IC. So backbone technology of that architecture we are seeing. So RISC stands for reduced instruction set computing. It's the instruction set architecture which is present in the ARM7, ARM7, ARM9, everything, every controllers. So these are some kind of features with this RISC, reduced instruction size, and instruction set, pipelining concepts. And one more thing, in order to increase the speed of our processing, we should have some kind of pipelining. So in the ARM7 architecture we have three-stage pipelining. So we will see what is that one. And the backbone, I mean, ARM7 architecture consists of load and store architecture. It's a memory architecture. So only two operations which are related to the memory. So first one is load and second one is store. That's it. So remaining all instructions will be executed on the basis of registers, not on the basis of memory. So it will be faster when working on registers. When working with the memory, it will be very slow. So why? Because every time we have to go to the memory and we have to fetch the memory, we have to decode these things. So memory will takes a lot of time. Memory will consume a lot of time. So the load and store architecture will speed up the things, and there will be some simple addressing modes will be there, like direct addressing mode extra. So it will be very easy to write the program in the assembly code itself. So these addressing modes will be useful whenever you are writing on the programs on the assembly languages, but most of the cases we will write our code in the case in the C language. So ARM architecture consists of load and store architecture. As I said, everything will be present. So I mean, everything will be on the basis of registers, not on the basis of memory. But with the memory, only two operations: load operation and the store operation. So everything will be based on the registers, and that too 32-bit registers. These ARM architecture having each register having 32 bits, and that 32-bit registers will be 16 number. That means there will be 16 registers will be there, and each register is of 32-bit size. So and one more important thing is, in this ARM architectures, every instruction is fixed length. That means 32-bit fixed length instruction. So it will be very easy. There will be no overlap, no mismatches in the while executing the instructions, so that the system may not hang up. So this is the one more reason why these ARM architectures will be popular. So, and most of the cases every instruction is executed in a single clock cycle. So normally in the case of 8051, addition, subtraction, all those things, every instruction has its own clock cycle numbers. I mean, the instructions which will take the clock cycles in order to execute those things. So in most of the cases, not in all cases. See, in the ARM architecture also there are some limited instructions that are maybe 2 to 3 instructions, that's it. So those instructions, only those 2 to 3 instructions will take more than single cycle. So remaining all 95% of all instructions will take single cycle. So that will speed up the executions. And the next one, see, in the market when you are going to buy one ARM7 architecture, you have to see what are the extensions available to that ARM7 architecture itself. You see, in the market there will be architectures, so based all the ARM7 architectures, with that some extensions will be there. So depending on application, depending on what you are doing, what you are designing your application, so the perfect architecture which suits to your application you should select. So first of all we should know what are the extensions and what those extensions means for. So all those things, the extensions will be like this. These are the most important extensions. So first one is the thumb, thumb. And we will see, I will explain. So second one is the Jagil, and third one is the DSP, and fourth one is the trust zone. In the case of thumb, see, as I said, every instruction is of 32-bit size. So whenever we are executing the 4-bit addition or 4-bit subtraction, so remaining all bits, remaining 28 bits should also execute. So this will take some time. So in the case of thumb, that 32-bit instructions will be divided into two parts, so 16 16. So whenever you are doing one 4-bit operation, only 16 bits will be taken care, and 12 bits will be added after that executed. So that is the advantage. So speed up it will, this thumb mode will speed up your execution. And the second one is Jagil. So in this Jagil, whenever you want to execute Java based applications, that means your games, whenever you want to play your games on one controller, so you need Java supporting to that controller. So if you have the Jagil extension for your architecture. That means you can execute your Java applications on the controller. So that is the advantages with the Jagil and DSP. See, we can't give direct analog signals to our application, so the signal processing should be like with this DSP extensions you can give directly. So that means analog processing will be possible with this DSP application, so signal processing will be possible with this DSP extension. And the trust zone, whenever you want more kind of security to your applications, so this is you should select this trust zone extension to your architecture. See, this is possible with the, I mean, most of the cases the high-end applications will require this much of security, so basic applications will does not need this trust zone. So in the market, not only the ARM, I mean in the ARM architectures, there are some kind of versions. The ARM 7 version, ARM 9 version, ARM 10, ARM 11, Secure Core. These are the ARM families. So each family is of, each family features differs from other family features. So you should select which family you want for your application and which extension you want for your application. So everything depends on our application, so that's why embedded system called as dedicated for dedicated applications. So these are the different kind of families which are available in the market. So see, most of the practical applications, in the most of practical scenarios, the ARM processors will be used in this phase. So in the real-time systems, so automotives, powertrains, networking control systems, like your hubs. So in the training operations, everything in the ARM process will be there. And entertainment process, your HDMI, I mean digital TVs, dish TVs. So in those things also ARM processor are using, and your smart cards, banking payments, your ATM, so ARM processors are using. So these are the practical examples where your ARM processors are using. So these are, see, as I said, ARM does not make any ICs. It will develop only, it will design only the architectures. So those architectures will be sell to different kind of companies. These are some kind of companies which are having this ARM architectures. So you can see the topmost companies will be there, like your Microsoft company and your Symbian OS. Normally this will be present in the case of your Nokia cell phones. Symbian OS, Dolby Digital Systems, Sun Java Systems, and Red Hat Linux Systems, your Wipro. See, these are all the companies which are having, these are the topmost companies to your Java. So all these things having this ARM architecture licenses. So these are some kind of products which are available in the market, which are based on your ARM controllers. So you can see your hard disks, so your cameras, your dish TVs, digital TVs, your printers, all these things will be your cell phones. All these products will have these ARM controllers internally in most of the scenarios. So see, actually this ARM architecture is designed based on the Berkeley RISC machine architecture. So the first controller is nothing but Berkeley RISC machines. So based on that architecture, this ARM architecture is developed. So while designing this ARM architecture based on the Berkeley architecture, some features of that architecture, Berkeley architecture, are taken and some are rejected. So we will see those things. So from the Berkeley RISC machine, while designing this ARM architecture from the Berkeley RISC machine, these are the features which are taken while designing. So load and store architecture is already present in the Berkeley RISC machine, and the same architecture is taken while designing this ARM architecture itself. So fixed length 32-bit instructions, 3 addressing instruction format, these are taken from the Berkeley RISC machine features. So some features are rejected, like register windows. See, register windows, in the sense we have 32-bit registers. So